what are the properties of the retina in the foveal and peripheral areas? Do we see color in the periphery? So fovea versus periphery. In summary, the density of the cones is highest at the fovea and drops really quickly into the periphery. That's known. And the important structures and the concepts I introduced today is the fovea, periphery, and the eccentricity. And I want you to introspect. What do you see in the periphery? And can you describe your experience in the periphery? And if you are interested, just stop the video now and then just write down what you can describe about your experience at the periphery. Okay. So in the last video, I mentioned that this rule of the thumb, really the rule of the thumb. This is across many people, Robert O'Shea measured, and then it's roughly the case that thumbnail width at your arm's length is 1.5 degrees. So if I locate somewhere around here, then that corresponds to 1.5 degree angle of visual angle in this thumbnail. Okay, and you try to do this in the next demonstration. And within this fingernail, that's where your vision is the most accurate, and you should be able to see it clearly. That's a fovea. Okay. And importantly for us, the cones and rods. Cones which respond to the different wavelengths, and rods that responds only to the brightness of the stimulus, and that's blind to the color, are distributed differently. So the rods devoid of the at the fovea, rods going to 0 here at the fovea, and then cones on the other hand is highest at the fovea, but it declines really quickly here, and then the density of the receptors goes really quickly, minimum, and here between this to this, roughly like 10 to 20 degrees of the eccentricity, there is a thing called blind spot, which is also important for our consciousness study. And the blind spot is basically the bundles of the optic nerves, axons. So here, across all these retina, all the bundles get together, and then that exits from around here to send the information to the brain. I also don't know why it locates relatively close to the fovea and not really far away. It's also one of the evolutionary mystery kind of thing. Maybe it's something to do with how the eye needs to move while we can still connect it through the nervous systems. I actually don't know. Anyway, so within this range of this blind spot, there's no cones or rods over there. Now, so the y-axis here is some kind of weird name of the thing called eccentricity. Eccentricity is the one defined by the angle from the center of the vision. So as I said, a fovea is located at 0 degree eccentricity, and here is what you are fixating on outside of the vision. And then let's say somewhere here is far away to the periphery. That's the minus 40 degree eccentricity, and here that corresponds to plus 40 degree eccentricity. So eccentricity is the measure of the angle that is different from the line of your fixation, and that is really defined by the angle of the deviation. This is very important. And another important issue is that the ataphobia, as I said, that there is no rod present here, right? And then you see that in this electron microscopy, you see what you see is all cones, and the cones of the mid wavelengths and the long wavelengths specificity. No short wavelengths, no blueness. That's what I said here. Within the 0.33 degree, eccentricity. And then as you go into the periphery, somewhere around here, you see cones rarely, and the density goes lower. And then what you see as a sort of spacing is this rods here. So rods are much, much smaller in its own, in terms of size, but the cones are much bigger compared to the rods. And also notice that the cones at the periphery is much bigger than the cones at the fovea. And this is the same scale, okay? So the cones are larger in the periphery, but smaller in the fovea. That's also important. Now, so let's do the phenomenological introspection again. First, adjust your distance from the display so that when you cover one eye, and then your fingernail corresponds to this figure. Okay, for me, this is the distance, and this is roughly 1.5 degree, eccentricity, and that corresponds to, somewhere around here. Okay, so there within this, fingernail, definitely you expect that there is a cones over there. But by the time it reaches to, let's say 10 degree, then we should expect the cones density should decline quite a bit. Okay, so that corresponds to, let's say, if this is 1.5 degree, this is 3, 4.5, 6, 7.5, 9. So around here, it's already 10 degree or so. Now, adjust your distance and then try to fixate at the center and then observe what you see in the next slide, okay? 3, 2, 1, 0. Okay, what did you see? I'll do it again. 3, 2, 1, 0. Don't move your eyes. All right, so the question is, did you see any color outside of the fovea? And then did you see anything clearly, sharply, richly? And I asked, shouldn't we suppose not to see much color outside of the fovea if you say that you saw the color? Well, what's going on here? Okay, next, one more time. But again, let's do it again. Adjust the distance, and then let's go 3, 2, 1. Same question. Did you see any color outside of fovea? Did you see anything clearly, sharply, richly? Shouldn't we supposed to see, not to see the color? And then if you're a bit skeptical about your own experience, show it to your friends and family. And we will discuss what this means in the further, in detail next week. All right, in summary, retina in the eyes is a sheet-like structure with cones and rods distributed unevenly across eccentricities. You introspect your color experience at fovea and the periphery. And you stop here and then try to think, can we explain the properties of our own phenomenology purely based on the property of our retina? Think about it and then try to write it if you have an explanation. And if you don't, then just declare that you have no idea. And let's see whether we can do better next week. All right, that's it. See you. Bye-bye.